Okay, let's talk about water treatment programs. Basically, there's 4 areas of water treatment that you need to look at. Certainly scale control, fouling, which is basically suspended solids that get sucked in the tower, corrosion. Obviously, we want to protect our piping, and we're able to achieve now less than 1 mil per year in steel and less than 0.1 mil per year in copper. Mil per year. A mil is 1,000. So it's so a case of steel, we can get less than 1/1000th of an inch corrosion on steel surface per year. That's pretty low. So the technology is pretty good with that. On copper, it's 0.1 mils per year. Remember that 25/1000th of an inch tube? We want to make sure we get very low corrosion rates to have those copper tubes last a long time. The microbiome, we pretty much have the parameters set of general aerobic bacteria at 10,000, colony-forming units, anaerobic less than 50 colony-forming units, and pipe surface bacteria less than 50,000 colony-forming units. Just to give you an example what 10,000 CFU means, this is actually 10,000 bacteria cells per milliliter of water. Okay, so you guys know an eyedropper. If you take 2 drops out of an eyedropper, that's 1 milliliter. In there, it has to be less than 10,000 bacteria. So you see, we're not asking for sterile water, but we don't want bacteria to be out of control. Okay, so we want to make sure we control the biological activity, and you'll learn a little bit about how that affects Legionella and everything else later on. Microbiome is in the center of that pyramid, and there's a reason for that. 90% of most cooling tower problems are a result of biological activity. 90% of all problems in cooling towers are a result of biological activity. Microbiome causes the fouling. Biological activity causes under-deposit, biologically influenced corrosion. Bacteria will consume your scale inhibitors as a food source because they're phosphonate based. So if we control biological activity, you pretty much have 90% of the problems licked. So let's talk about biological activity. There's basically 3 quadrants of bacteria. Aerobic bacteria, these are bacteria that live in an oxygen-rich environment. Okay, you think about cooling towers, it's kind of an oxygen-rich environment. There's anaerobic bacteria. These bacteria live in a non-oxygen-rich environment. So you might want to ask, where in a cooling tower system is there no oxygen? Okay, well, if you have a lot of mud and sludge in your cooling towers, underneath that mud and sludge, there's really not a whole lot of oxygen. If you have deposits or tubercles, these are the rust bumps, if you would say, on piping, they kind of are inside of that thing. Have you ever done condenser inspections and you see the tube sheet, you get the little bubbles and you pop them? You know, some goos come out of there. That's anaerobic bacteria that's growing in there. So there are places within the system where anaerobic bacteria does grow. And then, of course, we got algae. Now, we don't see algae in condensers because there's sunlight. The only place we see algae is where there's sunlight. So if you can find a way to enclose your cooling tower where there's no sunlight, life is good. You won't see algae. And then, of course, there's Legionella. And we'll talk a little about that in a little bit later segment. What we normally find around the country is that if you control your aerobic bacteria to within normal standards and performance standards, we normally don't see issues with Legionella. Now, that might vary a little bit with healthcare. We'll talk a little bit about that a little bit later. Okay, so what's the impact of biological activity? When you're talking about biological activity, and these are corrosion coupons. If you've ever seen coupons, they're pre-weighed metal strips, either copper, and this one happens to be copper up here. This happens to be steel here. This actually was pulled out of a cooling tower system in the south. The black streaks you see right here is not general corrosion of a coupon. This is all biological growth growing on the coupon itself, which simulates what could be growing on your pipe surfaces, your tube sheets, or everything else. And underneath this stuff is what's causing the corrosion, and that's called biologically influenced corrosion. Notice that there wasn't anything growing on the copper. Well, that's because the metallurgy of the copper surface is a little smoother than that of a steel surface, so the biological activity have a tendency to grasp onto steel versus copper so much. Okay, there's 2 types of biological activity. We classify them in 2 areas. One is planktonic, one is sessile. Planktonic basically is bacteria that's floating around in the water. It's actually going around your system, around the system, and it picks up in the air washers from the towers and floating through there. These bacteria don't just like swimming. They need to take a break. No, just kidding. They don't really take a break. They actually come in contact with the metal surface and they attach themselves to the metal surface. Well, what they do is they establish residence there. Okay? So once they establish residence here, they basically start growing into microcolonies, then they start growing into what they call biofilm. Okay, and this is what's growing up here, and at the pipe surface and interface of that biofilm, that's where corrosion can occur. And it's pitting corrosion. It actually digs down into the metal surface and causes some very damaging pitting corrosion. This biofilm, because it grows at certain points and grows to certain levels and heights, because of the flow, actually discharges and leaks itself back out into the system that goes around the tower, and it finds a way to establish residence somewhere else. So if you don't control both the biological activity in the bulk water, which is the planktonic cells, and find a way to have a program that controls it on the pipe surface level, then you might be missing the boat. Because this is where the damage is done. Floating around the water doesn't cause any damage. So most people that do the bacteria dip slides on the water, they say, oh, my bacteria is good, things perfect, life's good, but they wonder why they're seeing corrosion on their coupons or seeing corrosion in the system. It's because they're not dealing with the sessile bacteria on there. And we'll talk about biocide programs in a little bit. So just so you're aware that just because you measure biological activity in bacteria strips doesn't mean you have a good and healthy system. One of the ways that everybody seems to, and probably the best way to from a field perspective is to measure bacteria is through the dip slides. You've probably seen their Hawk dip slides or the Orion dip slides. And basically what they do is they have an agar solution. They have an agar nutrient solution on the paddle wheel itself. Okay, you dip that in the water, allow the water to attach to the surface, of the agar solution, and you incubate it for 24 to 48 hours, depending on what methodology you use. On that agar solution, bacteria colonies will grow. Okay, they will actually grow in a very rapid period of time. And then from there, you can actually outline where you are from a biological activity. So 10 to the fourth is 10,000 cells per milliliter, 100,000, a million, 10 million. 10 million bacteria per milliliter of water. We want to be here or below. Here and above, you got a problem. Okay, that's where you can start having biofilm. That's when you can start being susceptible to Legionella because the activities are very high. So it's a great methodology in the field in order to determine whether or not you're in control or not in control. Remember, this is only bulk water. This is not surface. Okay, so types of biocides. There's basically two types of biocides. There's both oxidizing and there's non-oxidizing biocides. Oxidizing biocides you're probably familiar with. These are chlorine or bromine. Most municipal plants use chlorine for disinfection of their water supply systems. Use chlorine in pools and spas, even though spas should probably be bromine. But they're basically oxidizing biocide, and you understand there's like sodium hypochlorite, which is bleach. Bromine comes in a couple forms. It comes in a liquid form, which is a stabilized bromine, or it comes in a solid form, bromine tablets. Chlorine also comes in tablets. It also can come in a gaseous stage. We don't see too many people using gas chlorine that much anymore because that's kind of explosive. So basically, everybody seems to use the liquid or the pellet form. Chlorine's got a disadvantage in cooling towers in that it is pH sensitive. So once the pH gets above about 8.1, 8.2, the ability for chlorine to kill goes down. When you're running a pH of about 9 in a cooling tower, the chlorine effect is about 10% or less. So if you have a 10% bleach solution, of which 10% is only really active, you basically only have a 1% solution. So most people use the bromine, and bromine does a much better kill at higher pHs. Most of the best practices, including the Cooling Tower Institute guidelines, recommend both an oxidizer and a non-oxidizer, the oxidizer being your primary source of biocide. Why? It's inexpensive, fairly inexpensive. Two, it's very, very rapid kill, and it's easy to apply. A non-oxidizing biocide is predominantly used in conjunction with an oxidizing biocide because it has a tendency to be more of a poison type effect. It basically is a poison you're adding into the water, okay, where biological activity will consume that poison in some methodology, and we don't have time to discuss that, and then it basically kills them. What's nice about non-oxidizing biocides, it does a very good job with the sessile bacteria, the bacteria on the pipe surfaces. For example, glutaraldehyde is one of our primary choices that we like. This actually will help penetrate biofilm, kill anaerobic bacteria, and allowing it to leach out so that the oxidizing biocide will have a chance to do kill in the bulk water. So you really need a combination of both. The feed frequency depends on your system. Some systems are more susceptible to biological activity, some are not. So you need to adjust your biocide dosage based on what you're seeing in the program itself. But you can see there's a whole slew of them. Glutaraldehyde, isothiazolone are the two biggest ones. DBNPA, there's chlorides, carbamates, quaternary ammonium compounds. They're all fairly active. They are poisons. They are biocides. They will hurt you. They will hurt. So you need to make sure you take proper PPE when you're applying these biocides. Or in the case of the isothiazolone, make sure you have the special cream that helps you out from that program right there.